Hey everyone, I ran into a nice search and filter example today from Kyle. I thought it'd be a nice component test, and if maybe I could try a daring refactor. So what we have here is a list. We can add new items to that list, and we can filter that list for the items we need and clear it. So that makes it clear what we're working on. The component test looks as such. Mount the application. We have an array of items that we feed into the list, type each one in, and then once we have built the entire list, we go ahead and search in the search item. So we just type BA, and then make sure that there are only 2 items in the list. We clear this input, and then make sure that the original length of the list is still the same and it's filtered again. So that's a pretty confident test for some search filter functionality. The source code, there's basically a key idea about it. We have 2 sets of state, one of them for these items. So items and set items is for that, right there above here. And then the other one is for the query that you're typing in. So that's the other piece of state. And the input ref is effectively what you're typing in the new item. So the way it works is when we're submitting an item, when we're adding a new one, let's say df, we are getting that input reference, which is tied to the form input right here. And then once we add that, we're updating the state for the items. And then finally, that state is updated. And then finally, we make sure that if this reference's value is empty, we have the list filtering out again. Right here, I was typing wrong. So when it's cleared, we have the item again, and this line 17 makes that happen. For filtering these, we are deriving the state from the 2 of them. So we have an items, and then we have the query. And what this does is if the query is included in any of the items, filter that out. We wrap that in a use memo to make sure that we don't cause a re-render unless items or the query, so the state that we're concerned with, changes. So it's a good example of derived state and just using the state that you need. In this case, the list is what we need and the search is what we need, and everything else, like the filtered items, we can derive from that. So I thought, okay, maybe I can make this part of the code a little better, because what happens when we have white space in the search item, number 1. And number 2, we effectively handling empty strings. So I thought, okay, let's use Ramda for this. So at first, what we're doing is, as the submit is happening, this path or is basically, we get the input ref, which is the data we'll be feeding in later. If there's a current .value path through it, we get that value. And if there's no such path through it, we get nothing. That's the path or from Ramda. Trim is just like .trim, the string method, just making sure that when we're getting this new item, when we're typing something in, if there is empty space, we trim that out. So we're adding a little more security to how we're getting that new item that we're typing in. The way things work with Ramda is you feed the data / the argument later. So first you build your functions, and you build a pipeline with pipe. So first we're going to get this data. It's going to get fed into path or function. We're going to get a value from there, and then we're going to trim it. Right? So think of it, data is coming after, but we have this pipeline of functions that's going to shape the data whenever the data is ready. We acquire the new item value from there. So whatever we typed in, let's say df is our new item value. Next thing we have to do is we have to update this list, right? So we have some conditionals here, effectively replicating line 14. So if there is nothing, if it's empty, so we have to push a predicate. Is empty is a utility function from Ramda saying, okay, if you have like an empty string or any of these, it's going to return truthy. So if it is truthy, we do nothing. Noop is just a function returning an empty object. They don't have it in Ramda, so I took it from Lodash. But I could write my own, but I didn't want to. It's just simple. So if the string is empty, we do nothing. So that is effectively just that line, right? If else. Otherwise, we do the same thing with it here, setting up the state, so setting items. So we make sure that it is effectively duplicated code from up there. But making sure we're not mutating the previous list at all. And then we're just adding the new item, new value on top of it. And the same thing that we did here, right, is here. And of course, this could be another const to make things a little readable. Right? Like const set new value if you wanted to, right? You could do this. And that's fair, right? You can do that. So when updating the list, if what we're getting it, what we'll be getting from the get new item is empty, we do nothing. Otherwise, we set it. And finally, the main function that we're building is build new list. What this does is first it gets this new value that we type in right here, and then it updates the list. And it only runs when we pass in the argument. And effectively, the rest is the same, right? So we to prevent default for all this is build new list. It may seem a little longer, but it's doing a little more trimming and making sure about the white space and the emptiness in case. And then the final line is the same. I think this could be a refactor, one more layer, but that's going to make the comparison a little obscure, a little less obvious between the two ways of doing it. Anyway, so at the end, all we do is just use a different handle submit. So the second one is handle submit R, save it, read on the test, and it works exactly the same. So I think this is an excellent example of a daring refactor. Once you have pretty confident component tests, you can still, after having run the test, you can still play around with things, right? And which, not new item search, right? Which is, I mean, what sets component testing apart. You can basically go and ad hoc your component in isolation, which is just a game changer. Now, let me know which one you like better. Right? I think the code in the bottom is, if you can get used to what Ramda is doing, it's much easier to read. So your intent here is to build a new list, and in order to get that new list, you get that, build that new list, you get that new item, and then you just update. And the conditional logic one-liners are quite readable. Just needs a little familiarity with the Ramda library, but I like this version a lot better. I think Ramda is, it can be quite useful in refactoring uh, imperative React code or anywhere, but this is just a React example. I'm going to push this to the Cypress component test examples repository. And if you have any ideas on how to make it better, let me know. Otherwise, enjoy.